Bismillahirrahmanirrahim. Inshallah, today I'd like to give you some examples with arithmetic and geometric sequences. Here we have some instructions for each sequence over here. We are requested to state if it is arithmetic, geometric, or neither. So we're supposed to figure out, just given these, which one it is. So 1, 3, 6, 10, 15. So let me just write that down. 1, 3, 6, 10, and 15. So I just want to make sure I have it correct. 1, 3, 6, 10, 15. That's always important to make sure that you check and you didn't do something silly as write it down incorrectly. And I've done that plenty of times to learn that lesson. Okay, so here we're supposed to figure out if it is arithmetic or geometric sequence. Now, if a sequence is arithmetic, then it should have a common difference, correct? That's the key. So it should have a common difference. So in other words, from here to here, and from here to here, and from here to here, from here to here, it should be the same. So from here to here, we added the 2, so the 1 plus 2 will give you 3, and from 3 to, and here you're adding 3, and here you're adding 4, and here you're adding 5. So clearly it's not a common difference. So it is not arithmetic sequence. Okay, so perhaps it is geometric sequence, right? If a sequence is geometric, then you must have a common ratio. In other words, this divided by this must be this is the same thing. Okay, so let's figure out. Here, to get from 1 to 3, you have to multiply by 3, right? And to get from 3 to 6, you have to. Well, it looks like you're multiplying by 2. And you get from 6 to 10, you multiply. So clearly it's not going to be the same. If you ever want to figure out what the ratio is, the easiest thing to do is multiply like 2 terms, like 10 divided by 6 over here. So let's do that. Okay. We already know it's not geometric, but it's 1.66 over here. So according to these 2 terms, it is 1.66 is the common ratio. How about 15 divided by 10? That's 1.5. Okay, so clearly it's being multiplied by different numbers. So and so it's not even a geometric sequence. So this one is neither or neither, however you say it. Okay, so this is neither. Okay, so let's do this one. 13 over 3, 14 over 3, 5, 16 over 3. Okay, so my goodness sake. So let's do this one. 13 over 3 and 14 over 3. Okay, and 5 and 16 over 3. Okay, I have no idea what's going on over here, so I'm just going to be methodical again. Okay, so first thing, let's just make sure we copied it correctly. 13 over 3, 14 over 3, 5 and 16 over 3. Alright, so let's just make sure. 13 over 3, 14 over 5, 16 over 3. Okay, if this is arithmetic sequence, then it must have a common difference, and that's typically D, as you recall. So I'm going to do this on a calculator. Okay, so if that is the case, let me get my handy dandy calculator here. So it's, let's see, 13 over 3 minus 4. Okay, so I'm going to do this in a calculator. 13 divided by 3 minus 4, this comes out to be 1/3. Okay, 0.33 or 1/3. All right. So, and then 14 over 3 minus 13 over 3, common denominator, that's 1/3. Oh, okay, that looks pretty good. So far, so good. Okay, how about 5 minus 14 over 3? Let's do this one. Okay, that's 15 over 3 minus 14 over 3. Hey, that's 1/3. That's pretty good. Common difference. How about 16 over 3, just to make sure we're not fooled. Okay, let's get the common denominator again. Okay, so that is 16 over 3 minus 15 over 3, that is 1/3. So you can see every time you're adding 1/3, okay, and that is going to be an arithmetic sequence. Okay, so the thing to do is find the difference between you subtract this one from this one, this one, this one, this one. If they're all the same, then it's the common difference, and the common difference is 1/3. Okay, so this is an arithmetic sequence. Okay, that was good. At least we got one there. Now let's see, we have another one. Okay, how about number 3? Let's do number 5 over here. I'm just trying to do odds. 4, 16, 36, 64, 100. 4, 16, 36, 64, 100. Okay. 4, 16, 36, 64, 100. That's what I thought I read. Let's just double check. 4, 16, 36, 64, 100. 4, 16, 36, 64, 100. Okay, let's see. Is this arithmetic? Now, I'm not the best speller on the planet, so make sure you don't copy my spelling mistakes. If it is arithmetic, then it must have a common difference. Okay. Alright, so if to find the common difference, so from here to here, 16 minus 4, that is 12. And from here to here, 16 minus 36 is 20. Oh, that's clearly not going to work. Okay, just for the sake of completeness, let's do 64 minus 36. That's 28, and that's 36. So that's not going to be arithmetic. So we figured that one out because it's not a common difference. Perhaps it is geometric sequence, huh? Okay, so if it is geometric, okay, then it must have a common ratio, R, okay? So, which means that 16 divided by 4, and 36 divided by 16, and 64 divided by 36, and 100 divided by 64, they all must be the same, okay? That would be the common ratio from here to here. So that's 4, it's clearly not 4, that's clearly not 4, so as you can see, well, we can humor ourselves and try to complete the 36 divided by 16 is 2.25, okay? And then we have 64 divided by 36, that's 1.7, like this. And then 100 divided by 64, that is 1.5625. So this divided by this, okay, or multiplied by, this is 4 over here it's 2.25, over here it's 1.7, like 7, and from here to here it's 1.5625. So this is also not geometric. So this is neither or neither. Okay? Okay. So that's that example. Let's do another one. I like to do it. 1, 5, 25, 125, 625. So 1, 5, 25, 125, 625. I hope I copied that wrong. Oh, we copied that right. 1, 5, 25, 125, 625. Okay, so that's correct. So I can tell clearly it's not going to be arithmetic, right? From here to here, adding 4. From here to here, add 21. So forget arithmetic, right? It's not going to be arithmetic. Is it going to be geometric? If it is geometric, then it must have, what must it have? A common denominator? No. A common ratio. You know better than that, right? It's a common ratio and sometimes a little r, which means this divided by this, 5 divided by 1 is 5, right? 25, 5, and 5, and 5. So the common ratio, as you can see, it's all times 5 times 5 times 5 times 5. So this common ratio r is 5, and this is a geometric sequence. Okay? So we did that one. Okay. Now we're still doing these over here, and now you're given a rule. See, we're given a rule over here. I like to do these two before I finish, inshallah. Now here we're given a rule, and we're asked to see if this is a geometric sequence or an arithmetic sequence. So an equals negative 163 plus 200n. So let's write this down. An equals negative 163 plus 200 times n. So, okay, negative 160 plus 200 times n. Okay, so we're supposed to find out if this is a arithmetic or geometric sequence. Okay. Now, I can tell it's going to be arithmetic only because I know, but the way you're supposed to do is like, okay, you know, we just write out a few terms, okay? If you don't know, if you're not told, then n starts with 1. So a sub 1 is going to be negative 163 plus 200 times 1. Okay, that's just negative 163 plus 200, right? So that's going to be, come on, negative 163 plus 200. That's 37. So that is 37. And then I'm going to do a sub 2. That's 163 plus, and it's just 400. Okay, n times that's 2. Okay, let me just do some progressive logical reasoning here. Do it slowly. Okay, that's 400. So negative 163 plus 400. Okay, so 400, 237. Okay, this is 237. Okay, and then I'm going to do the third one. That's negative 163 plus 200 times 3. Okay, this is like 600, right? Okay, that's going to be 437, I can tell you, right? But let me just do that. 400 is 600. That's 437. Okay, so, and a sub 4, if you were to do all of this, would be, what's it going to be? 637, because as you can see, you're adding, okay, every time you're adding a 200. Okay, so this is an arithmetic sequence. Now this is an interesting example because you can almost recognize this. This is y equals b plus mx. See, so the slope, so to speak, it's kind of like linear as that appearance. The common difference, see, that's what it is. The slope is the common difference. The rate of change here is constant. The rate of change is 200. So this is a example of a arithmetic sequence. Okay, and finally I'd like to do the last example before I finish, and this one says negative 4 times negative 3 n minus 1. So the rule is a sub n equals negative 4 times quantity negative 3 to the exponent of n minus 1. I just want to double check myself. Okay. I'm going to take a wild guess. This is going to be geometric, but you know, let's just do it. I know this is going. Let me tell you why I think this is going to be geometric. See, a geometric sequence is explicit rule is like this. Okay, so it's a sub 1 times, okay, the common ratio r to the n minus 1. Okay, this is how I know. And for an arithmetic sequence, the explicit rule was a sub n to a sub 1 plus, okay, the common difference times n minus 1. Okay, the previous example looked like this. Okay, this current example looks like that. In fact, you should recognize this. Okay, we will do enough of these, hopefully, that inshallah, that you'll be able to recognize that this is a geometric sequence without having to do what I'm going to do now. So, but this is a sub 1, okay, and so to speak, and this is like this, n minus 1 over here. But sometimes it's trickier because they can manipulate this into different forms, so they don't look as readily like this one does. This is easy to recognize this one because it's in the explicit form of a geometric sequence like this. Okay, but let's just do this. A sub 1 equals a sub 2 equals a sub 3 equals, and hopefully you'll see a pattern. So a sub 1 is when you substitute 1 over here, so you get negative 4 times negative 3 times 1 minus 1, which is 0. This is just 1. Negative 3 to 0 is 1, so that's negative 4. So I told you that the first term is negative 4. Okay. Alright, so a sub 2 is negative 3 times 2 minus 1. That is negative 4 times negative 3 to the power of 1. That is 12. And the a sub 3 is negative 4 times negative 3 times 3 minus 1. That's negative 4 times negative 3 squared. Now be careful here with the math. Okay, this is negative 4 times 3 squared is 9. And that is negative 36. Okay? Okay, that's negative 36. Okay? So just be careful with the math. That's negative 36. Okay? And a sub 4 is going to be negative 4 times negative 3 times 4 minus 1. Okay, every time, as you can see, you're multiplying by negative 3. So it's going to be negative 4 times 3 cubed, negative 3 cubed. So this is going to be a negative times negative, it's going to be a positive. So 3 cubed is 27 times 4. That's 108. Okay, so from here to here, okay, the common multiplier is negative 3, and if you do it negative times negative 3 and then times negative 3, as you can see, every time you multiply. Now if you did this and you still didn't know what the multiplier is, the way you would find out the multiplier is you would do 12 divided by negative 4, and that's negative 3. And then from here to here, you would figure out the multiplier by 36 divided by 12, and that's negative 3. And then here to here, you would do 108 divided by negative 36, and that is negative 3. And then you will see the same multiplier, that is the common ratio. So that's the common ratio is negative 3. And so this is a geometric sequence. Okay. Alright, so in general, just as a summary, I just want to remind ourselves that an arithmetic sequence explicit rule is a sub n is a sub 1 plus n minus 1 times difference. And for a geometric sequence, okay, and for a geometric sequence, the explicit rule a sub n is a sub 1 times the common ratio to the exponent n minus 1, as it is over here. So these are the explicit rules, and as it requested to you before, you should really memorize those, and that are very, very, very helpful. So these are some examples, just so you're comfortable. I request you to do a lot of such examples, so you become very thoroughly comfortable with the rudimentary concepts of arithmetic and geometric sequences, and we shall elaborate on this next time. Until then, as-salatu wa-salamu ala rasulillah wa alhamdulillahi rabbil alameen. Assalamu alaikum.